Today's scene, soil absorption capacity. Bugungi taqrib to'proqning sing'iruv qobiliyati. Plan of the lecture. Darsning joshlari. Soil colloids. To'proqning colloidlari. Classification of absorptivity. Sing'iruv jikteluvi. The importance of colloid in soil fertility. To'proqning xudarlig'idagi colloidlarning ma'nosi. Soil colloids. The soil phase of the soil is a complex polydispersed system consisting of particles of various size from large in the bracket sand, gravel, to the smallest in the bracket silty and colloid level. Due to the content of fine particles and the porosity, the soil is capable of retaining certain substances coming into contact with it. Soil colloids are particles with size from 0.2 to 0.001 micron. The quantity in the soil varies from 1 to 40% to the mass of the soil. By origin, colloids are mineral, organic, and organomineral. Mineral colloids are formed during the weathering of rocks. Organic in the process of humification of plants and the animal residues. Organomineral in the interaction of mineral and organic colloids. Most of all colloids in clay soils with a high content of humus, the least in sandy and the sandy loamy. With colloids such properties of soil as water regime, the dynamics of nutrients intake are associated. They are cementing and gluing substance in the formation of the soil structure. The structure of the colloidal particle in the bracket micelle, fig 17 in the bracket, regardless of the chemical composition, the following components are distinguished in colloids. On the figure 17, view structure of the soil colloid micelle. A colloidal particle, together with layers of iron on the surface, is called a colloid micelle. In the aqueous medium, the micelles may also not always be separated from each other by a solution called intermicellar or intermicellar solution. The inner part of the micelle is the core. Chemically, the nucleus is a complex compound and has an amorphous or crystalline structure. In mineral soil colloids, the core consists mainly of aluminum, magnesium, and other silicates, and sometimes of silicic acid, iron oxide, and aluminium. Mineral colloids are usually stable and destroyed only for a long time. Organic colloids have a core consisting mainly of humic acid and fulvic acid protein, fiber, and other complex substances. Organic colloids are less stable and can compose and recreate from the decomposition products of plants and animals. On the surface of the nuclei of colloids, there are two layers consisting of oppositely charged ions internal, i.e. connected with the nucleus. Ions are called potential determinant and external compensator. The boundary separating the potential determinant ions from the nucleus and from the compensating ions are shown in the figure by the bold line. Potential determining ions in soil colloids usually have negative electrical charges and the compensating ones positive. The total number of positive and negative charges for a particle is the same. Compensating ions in soil science are called exchange or absorption. The sum of the quotient is the capacity of soil absorption. A considerable part of the absorbed quotient is located next to the potential determining ions and forms a fixed layer of ions. A small part of the absorbed quotient located at some distance from the potential determining ions forms the so-called diffuse layer. The outer circle in the figure indicates the micelle boundary and simultaneously the boundary of the diffuse layer. The core of a micelle together with potential determining ion is called a granule. A granule together with a fixed layer of compensating is called a particles.